All right. Today I'm going to look at an example of the application of tangential normal coordinate system. This example, a plane flies a parabolic path at constant speed v, and we are interested in finding the speed such that the pilot experiences a maximum acceleration of 50 meters per second squared. So we need to know where the maximum acceleration occurs, and then we need to essentially solve that for our speed. If we were to write, so this plane flies over this path, starts from here, goes down, and then goes up. The curve, the parabolic path, is described with this equation: y is equal to 0.4 x squared. In Cartesian coordinates, if we were to write down the general form of position for this plane, it would be r I hat j hat k hat x y z. Because the plane travels on this plane, essentially there is no z component. Y component is 0.4 x squared. So this is going to be I hat j hat k hat x 0.4 x squared and 0. In other words, for any point on this path, the x component is equal to x, the y component is equal to 0.4 x squared, and z component is equal to 0. Now, in tangential normal frame, we have r double dot, the acceleration, equal to s double dot e sub t hat plus s squared over rho e hat n. So for any point on this path, our e hat t is tangent to the path, and e hat n points towards the center of curvature. In this frame, which makes it easier to attack this problem, the acceleration is equal to s double dot e hat t plus s dot squared over rho e hat n. The first component, s double dot e sub t hat, is only non-zero if the speed of the plane was changing with time. Essentially, the first term reflects the change in magnitude of the speed, and it is equal to 0 because we say a constant speed. Because of constant speed, s dot is equal to v equals to constant. Therefore, s double dot is equal to 0. Now, to compute the second component of acceleration, the component which points towards the center of curvature, we have s dot squared over rho. Therefore, we need rho, the radius of curvature from calculus. First year calculus, we have rho equal to 1 plus y prime squared to 3 over 2 divided by y double dot. So if we have the equation for the path, we can compute y prime, which is the slope of the curve at any point, and we can also compute deflection at any point, which is equal to y double prime. Therefore, in this case, because we know y is equal to 0.4 x squared, we have y dot, y prime, and y double prime. So rho is equal to 1 plus 0.64 x squared divided by 0.8. Right? Now, this component of acceleration, because we already know that this goes to zero, first term. The second acceleration component is maximum when rho is minimum. And rho is positive function of x. The minimum occurs, therefore, when x is equal to 0. So rho minimum, which corresponds to s dot squared over rho maximum. Rho minimum is equal to 1 over 0.8 for when x is equal to 0. Right? Okay. So a maximum, and let's call it a sub n. So this is a, and let's call this a sub n. A sub n maximum occurs when s dot squared over rho divided by rho minimum. Right? Therefore is equal to 0.8 v squared. I'm replacing s dot with v. And we know that maximum acceleration should be equal to 50 meters per second squared. Therefore, we set this equal to 50 meters per second squared, and then we compute velocity. 50 meters per second squared, just pay attention to the units. It is 0.05 kilometers per second squared. So v squared, so 0.8 v squared is equal to 0.05. Therefore, v is equal to 0.25 kilometers per second. I forgot to mention that these are all in kilometers. So now this is what we are looking for. V is equal to 0.25 kilometers per second squared. All right. Have a good day.